Hello, I welcome you once again into Kenya Mathematics Classroom. In this particular episode, we are going to look at what we call the binomial theorem. What we call the binomial theorem. And in general, before we start with the binomial theorem, we are going to look at the general idea of binomials. Now, when we talk about binomials, binomial is a mathematical expression that is connecting two terms with either the plus sign or the minus sign. And so if you have an expression, say a plus x, this is a binomial because this is one term and this is another term and it's combined by the plus sign. Or you can have a minus x. This is also a binomial because a is a term, x another term. That is, so the two terms are combined with the minus sign, or the two terms are combined with the plus sign. So when we talk about binomials in general, it's a mathematical expression that is connecting two terms with either the plus sign or the minus sign. So take note of that. Now, before we look at the binomial theorem itself, we'll be looking at binomial expansion. Binomial expansion. Now, when we talk about the binomial expansion, then let's consider the binomial. Let's assume we have a plus x exponent 1. Now, a plus x exponent 1 is the same as a plus x. That is the expansion. But if you have a plus x exponent 2, this is the same as multiplying a plus x by itself. That's why we have a plus x exponent 2. That is, you multiply a plus x by itself. Now, when we try to expand this is what you are going to have. A will multiply all the terms of the second bracket, then plus x will also multiply all the terms of the second bracket. So a square, according to the first law of indices, you know that when you have numbers or variables of the same basis multiplying, when you keep one of the basis constants, you add the powers together. You realize that all these terms have powers or exponent of 1. But a raised to the power 1 is the same a, and that is why the 1 cannot be seen, but they have exponent of 1. So when you multiply a by a, then we are getting a square. Then a times x will give us ax. Then x times a is still ax, plus x times x will give us x squared. This is because when you multiply a by a, it has the same base, but the exponent is 1, 1. So 1 plus 1 will give us 2, according to the first law of indices. Then a times x is ax. Then x times a is the same as a times x, and that is ax. Plus x times x is x squared, because the exponent here is 1, the exponent here is 1. And according to indices, because they are the same basis multiplying, when you keep one of the s constants, we add the exponent together, 1 and 1. So 1 plus 1 will give us 2. So now we simplify this. In simplify this, we have a squared plus, don't forget that these two are the same terms. You have ax. The constant coefficient here is 1. The constant coefficient here is also 1. So 1 plus 1 will give us 2, and the term is ax. Then we have x squared. And so that will be the expansion for the binomial expansion for a plus x squared. Now, when we have a plus x cubed, this is the same as multiplying a plus x by itself 3 times. By itself 3 times. Now, don't forget that a plus x all squared is the same as a plus x times a plus x. And after expanding a plus x times a plus x, this is what we had. That means that in place of this will now be our a plus x. But in place of a plus x times a plus x, you can now substitute a squared plus 2ax plus x squared. So when we are multiplying a plus x by a squared plus 2ax plus x squared, then the a will multiply all the terms of the second bracket. Then the plus x will also multiply all the terms of the second bracket. This is x. So when we are doing that, take note that the a will multiply all these. Then plus x will also multiply all these. So in simplifying this, we are going to have a times, we have a squared plus 2ax plus x squared. Then the plus x will also multiply the same thing. That is plus x will also multiply a square plus 2ax plus we have x squared. So in simplifying this, a times a squared will give us a cube. And I guess you know the reason why it's a exponent 3, because the exponent here is 1. And because we have the same basis, when you keep a constant, 1 plus 2 will give us 3. Then we have plus a times 2ax will give us 2a square x. It will give us 2a square because we have a here, a there. So when we add the exponent together, we have a square. And I advise that if you don't understand these things, you just refer to my presentation on indices and you'll get what we are saying here. So this is plus a times x squared will give us x squared. Then x times a squared will give us a square x plus x times 2ax will give us 2ax squared. Then x times x squared will give us x cubed according to the first law of indices. So we simplify. The only a cubed term we have is a cubed. Then plus, then we have 2a square x. Then we have 2a square x here. We have a square x. Don't forget that the constant coefficient here is 1. And because they are of the same term, then 1 plus these two will give us 3a square x. Then plus, we also have 2ax here. We have 2ax square here. Okay, so now let's look at what is happening here. Now, when we multiply this by this, we are getting this. When we multiply this by this, we have this. And when we multiply a by x squared, don't forget, it is not x squared. It is a times x squared will give us ax squared. Okay, so this will give us ax squared, not x squared. So we have ax squared term here. We have another 2ax squared term here. And that will give us 3ax squared. And the only x cubed term we have is x cubed. So we have x cubed. I want to go over this again. Don't forget that we are trying to solve for a plus x exponent 3. And this is a times x times a. This is a plus x times a plus x times a plus x. And don't forget that a plus x times a plus x is a squared plus 2ax plus x squared, because we are already done with this expansion. So in place of all this, you can now substitute this, and that's what we have here. We are saying that if you have a plus x multiplying a squared plus 2ax plus x squared, then a will multiply all the terms of the second bracket. Then x will also multiply all the terms of the second bracket. So in doing that, that's what we have here. So a will multiply all the terms of the second bracket. Then plus x will also multiply all the terms of the second bracket. So a times a squared will give us a cubed. A times 2ax will give us 2a squared x plus a times x squared will give us ax squared plus x times a squared is the same as a squared x plus x times 2ax will be 2ax squared, because we have x here, we have x here, and the exponents are all 1, 1. So we have x times x squared, and that will give us x cubed. So in simplifying, the only a cubed term we have is this. But the a square x term, we have another a square x term here. This is 2a square x, and this is a square x. The constant coefficient here is 1. So 1 plus these two will give us 3a square x. Then we have ax square term here. Then we have 2ax square term here. Constant coefficient here is 1. So 1 plus the 2 will give us 3. Then we have 3ax square. And the only cube term, x cube term we have is x cube. And so this will be the expansion for a plus x exponent 3. Now let's assume that we are asked to expand a plus x exponent 4. Then it means that we are going to multiply a plus x by a plus x by a plus x by a plus x. And you know that a plus x times a plus x times a plus x, that's a plus x times a plus x times a plus x, is the expansion. That's what we have here. So we are now going to multiply a plus x by all these expansions. That means that as the exponent becomes larger, the expansion becomes tedious. So when you multiply a plus x by this, you also get the answer for this. Now when you expand this, then you get a exponent 4, then you have 4a cubed we have x, then we have 6a squared x squared, then you have 4a x cubed, then you have x exponent 4. Now, when you expand this, that is when you multiply a plus x by a plus x by a plus x by a plus x. This is what you are getting. And now I'm able to write this because we have a coefficient at the back of our mind. And that's what I'm going to teach you, because when the exponent gets larger, this binomial expansion becomes very tedious. And therefore, I'm going to explain to you how I was able to come by this answer. Now, when you're also given a plus x exponent 5, the expansion is a exponent 5 plus, we have 5 a exponent 4 x, you have plus 10 a exponent 3 x squared, then you have plus 10 a exponent 2, you have x cubed, then you have 5 a exponent 1, and it's the same as a, then you have exponent 4 here, then you have x exponent 5. So this will be the expansion for a plus x exponent 5. Now, I'm able to write this expansion. This a plus x exponent 5 means you are multiplying a plus x by itself 5 times, and it is very tedious. So as the exponent gets larger, this work becomes tedious, but I'm able to write the expansion because I have a coefficient at the back of my mind, and that's what I'm going to teach you. So in general, this is what we call binomial expansion. And the reason why we are going to apply the theorem is because when the coefficient gets larger, becomes larger, then the expansion becomes tedious. So that is how come we have this expansion. That's how come we have the binomial theorem in general. So when we talk about the binomial expansion, this is what we call the binomial expansion. Now, I am going to teach you what you call the Pascal triangle. And the Pascal triangle will help you with the coefficients of the expansion. Now, let's assume that we have the binomial, and the binomial is a plus x. If you have a plus x exponent 0, a plus x exponent 0 will give you 1. Because if you have any number of variables to the power 0, if you have x exponent 0, you get 1. 58 exponent 0, you get 1. If you have a plus b exponent 0, you still get 1. You can try that and see. So a plus x exponent 0 will give us 1. Then if you have a plus x exponent 1, this will be the same as a plus x. This will be the same as a plus x. I'm trying to generate the triangle. So what we are looking at is what we call the Pascal triangle. Okay, so we have the binomial here. If you have a plus x exponent 0, the expansion will give you 1. So if you have a plus x exponent 1, the expansion will be a plus x. So when I want to try to get you the triangle, so we have the coefficient to be 1 here. The coefficient of the a term is 1, and the coefficient of the x term is also 1. Now, if you have a plus x exponent 2, don't forget that the expansion we had a squared plus 2ax plus x squared. So the coefficient of the square term, the a squared is 1. Coefficient of 2ax, we have 2. And the coefficient of the square term here is 1. So if you also have a plus x exponent 3, this is a cubed plus 3a squared x plus 3ax squared. Then we have x cubed. If you remember, you can take the video back and find out the expansion for this. This is what we had. The coefficient of the a cubed term is 1. Then the coefficient of the second term here is 3. The coefficient of the next term here is 3. And the coefficient of the cube term here is 1. So you can see that we are generating something like a triangle. That's why we call it the Pascal triangle. Now, what is happening is this. When we start with the 1, that is the expansion a plus x exponent 0. We start with 1. then we end with the 1. If you look at the expansion for a plus x exponent 1, it's a plus x. So we have 1, 1. Then we start with 1. 1 plus 1 will give us 2. Then we end with 1. Now we start with 1. 1 plus 2 will give us 3. 2 plus 1 will give us 3. Then we end with 1. That means that our a plus x exponent 4. And if you remember, this was the expansion. A exponent 4. Then we have plus, we have 4 a cubed x. Then we have 6 a squared x squared. Then we have 4 a s cubed. Then we have x exponent 4. So you realize that the coefficient you have 1, 4, 6, 4, 1. How do we generate it? When we start with 1. 1 plus 3 will give us 4. 3 plus 3 will give us 6. 3 plus 1 will give us 4. Then we end with 1. So we have 1, 4, 6, 4, 1. So we have 1, 4, 6, 4, 1. And that's how we generate it. So you can generate it. That means when the a, you have a plus x exponent 5. You can also expand this, but when the coefficient is known. So I'm now going to teach you how to use the coefficient to expand. And that's how we generate the coefficient. I would advise that if you are getting confused, take the video back so you understand. So when you are asked to expand a plus x exponent 2, then remember that you'll be using the coefficient 1, 2, 1. I'm now going to teach you how to use the coefficient to simplify or to solve binomial expansion. But for now, that is how we generate the triangle. So you see that the nature is like a triangle. Now, if you want to find the coefficient for a plus x exponent 5, don't forget, you also start with 1. 1 plus 4 will give you 5 here. 4 plus 6 will give you 10. 6 plus 4 will give you 10. 4 plus 1 will give you 5. Then you end with 1. This will be the coefficient for expansion a plus x exponent 5. When you take the video back, you realize that this was the coefficient of the expansion for a plus x exponent 5. So now we are going to take a question and see how best we can use the Pascal triangle, the coefficient approach to also expand before we look at the binomial theorem in general. So we are still under the Pascal triangle. We are still looking at how to use the Pascal triangle to solve binomial expansions. Now, let's assume that you are given a plus x exponent 4. I want to teach you something now. Don't forget that the coefficient for a plus x exponent 4, you have 1, 4, you have 6, you have 4, 1. This was the coefficient. When you refer to the Pascal triangle, you realize that the a plus x exponent 4, the exponent 4 has the coefficient 1, 4, 6, 4, 1. This is the binomial. This is a term, and this is another term combined with the plus sign. So this is one term, another term. So now what happens is the first coefficient is 1. Then the a will start from here with the highest exponent. Then this term will also start with the least exponent of 0. Then we are done with the 1. Then we are now here. That is 4. A will now decrease from 4 to 3. And the x will now increase from 0 to 1. So as the a is decreasing, the x is increasing. Then we are done with the 4. Now we are here, 6. And the a will now also decrease from 3 to 2, but the x will increase from 1 to 2. Then the next coefficient is 4. So a will now decrease from 2 to 1, but the x will increase from 2 to 3. Then the last one will be 1. And a will now decrease to 0, that is from 1 to 0, but the x will increase from 3 to 4. So in general, that is how the expansion is being done. So this one, we have 1 times a exponent 4. Take note that x raised to the power 0 is 1. So 1 times all this will still give a exponent 4 plus. Then x raised to the power 1 is x. So 4 times a cubed times x will give us 4a cubed x. Then 6 times a squared times x squared will give us 6a squared x squared. Then this is 4a s cubed, 4a s cubed plus a raised to the power 0 is 1. 1 times 1 is 1. 1 times s raised to the power 4 is s raised to the power 4. So this is the expansion for a plus x exponent 4. So with the help of the coefficient, you are able to get the expansion, but that is the rule. So that is how you use the coefficient to expand. So if you are given a plus x exponent 5, then you can also use the coefficient for the a plus x exponent 5 or the exponent 5 expansion, and that will be 1. You know why I'm starting with the 1. Now this is the 4th expansion. Now this is the 5th exponent expansion. So we start with 1. 1 plus 4 will give you 5. 4 plus 6 will give you 10. 6 plus 4 will give you 10. 4 plus 1 will give you 5. Then you end with 1. And you use the same approach as the first term is decreasing, then the second term is also increasing as I did the expansion here. So that is how we use the coefficient to do the binomial expansion. That is how we use the coefficient to do the binomial expansion. Now, a plus x exponent 5, the coefficients are, you have 1, you have 5, you have 10, you have 10, then you have 5, then you have 1. So if you want to expand, this is what you do. The first coefficient is 1. Then the a will now start from the highest exponent. Then the x will now start from 0. Then you move to 5. Now the a will now decrease from 5 to 4. Then the x will increase from 0 to 1. Then you move to the next term, that is 10. Then the a will now decrease to 3, but the x will now increase to 2. Then you move to the next coefficient. A will now decrease to 2, and x will now increase to 3. Then you move to the next coefficient, that is 5. Then a will now decrease to 1, but the x will increase to 4. Then the next coefficient is 1. Then the a will now decrease to 0, and x will increase to 5. So you try to simplify this. Then x raised to the power 0 is 1. 1 times a raised to the power 5 times 1 is a raised to the power 5 plus. If you simplify this, you are getting 5a exponent 4 times x. Then you are getting 10a cubed. You are getting s squared. Then you have 10a squared s cubed. A squared s cubed. Then you have plus 5a. You have x raised to the power 4. Then a raised to the power 0 is 1. 1 times 1 is 1. 1 times s raised to the power 5 is s raised to the power 5. So this will be the expansion for. This will be the expansion for a plus x exponent 5. So in general, that is how we use the Pascal triangle to expand. That's how we use the Pascal triangle to do binomial expansion. So if you have a plus x exponent 6, then you can also generate the coefficient. If the exponent 5, if this is the coefficient for exponent 5, and you are given a plus x exponent 6, then you start with 1. 1 plus 5 will give you 6. 5 plus 10 will give you 15. 10 plus 10 will give you 20. 10 plus 5 will give you 15. 5 plus 1 will give you 6. Then you end with 1. That will be the coefficient for a plus x exponent 6. Then you do the same thing I'm doing here, and your answer will come out at the end. So in general, that is the binomial expansion thing we are talking about. That is the binomial expansion thing we are talking about. Now, let's take a look at the question. And this is the introduction of the binomial theorem. This one, we are looking at the binomial expansion in general. We are looking at the binomial expansion in general. So this one, even with the Pascal triangle, that is using the coefficient, constant coefficient, to solve for expansion. When the exponent becomes large, it is also tedious in simplifying. Now, let's assume that we are asked to expand. We have 2x plus 3y exponent 3. Now, let's assume that this is what we are given to expand. Now, you know that this will be the same as multiplying 2x plus 3y by 2x plus 3y by 2x plus 3y. So we multiply this by this. When we are done, we multiply the result by this, and it's very tedious. But you know that with the exponent 3, the coefficient should be at the back of your mind. You should know. As you continue solving a lot of questions, you will get the coefficient. Now, the coefficient for exponent 3 is 1, 3, 3, 1. You can refer to what you did, and you know why the coefficient for exponent 3 is 1, 3, 3, 1. And so, if you have 2x plus 3y cubed, then you start with the first coefficient 1. Then your first term is now 2x. That will start from the highest exponent 3. Then the second term, 3y, will start from 0. Then you are done. Then you move to the next coefficient. That is 3. Then the 2x will now decrease from 3 to 2. Then the 3y will also increase from 0 to 1. Then the next coefficient is also 3. So we have 3. Then 2x will now decrease from 2 to 1. But the 3y will also increase from 1 to 2. Then the next coefficient is 1. Then you have 2x decreasing from 1 to 0. And the 3y increasing from 2 to 3. Then you simplify. So we have 1 times anything, we are getting the same thing. So we have 2x all exponent 3. And according to indices, the exponent is affecting both the 2 and the 3. So 2 raised to the power 3 will give you 8. Then we have x exponent 3. 3y all power 0 will give you 1. Then we have plus. We have 3 out here. Then 2x all square. 2 square will give us 4. Then we have 4x squared. Okay, so 3y exponent 1 is the same as 3y. Then we have 3 out here. 2x exponent 1 is the same as 2x. 3y all square. 3 square will give us 9 and y square. Then we have plus 1. 2x exponent 0 will give us 1. Then 3y all cube. 3 cube will give us 27. Then we have y cube. So we now simplify. Then we have 8x cubed plus. Now we have 3 times 4, that is 12. And 12 times 3 is 36. So we have 36. We have x squared here. Then we have y here plus. Then we have 3 times 2 here will also give us 6. And 6 times 9 will give us 54. So we have 54. Don't forget you have x here. And we have y squared term here plus. Then this 1 times 1 is 1. 1 times 27 is 27. So we have 27 y cubed. So in general, this will be the expansion for the question we were given. That is 2x plus 3y all cubed. So that is how we expand using the coefficient. So you see that even with this expansion to the exponent 3, look at how tedious it is. So assuming you are given 2x plus 3y exponent 7, then it will be very tedious. And that is why we apply the binomial theorem. But for now, what we have talked about so far is the binomial expansion. In our next presentation, we will start with the binomial theorem in general so that you will appreciate what we are talking about here. But for now, that will be all for now on this particular episode. Thank you.